We're live.
All right, welcome to Community Office Hours for Consul. We have borrowed Terraform Thursdays because I think this is an important product that goes between Consul and Terraform. So why not do a Consul Office Hours on a Terraform Thursday? I'm your host, Rosemary Wang, and today we've got an open Q&A with the Consul-Terraform-Sync team. Is it okay if I refer to you as CTS from now on? Because this Consul-Terraform-Sync is a bit of a, okay, thank you. It's a bit of a mouthful. We've got an important announcement. If you haven't heard already, we have Hashi Talks happening next week on February 17th to 18th. We had so many amazing community speakers submit that we ended up going 2 days. So do tune in. If you want to check it out, sign up, view some of the events, definitely take a look. I'll drop the link in chat coming up. Okay. All right, as usual, if you have questions or comments for the team or in general about Consul or Terraform, we'd love for you to interact with us in the chat. As you do keep in mind our code of conduct in this virtual space. In general, be welcoming, inclusive, friendly, and patient, be considerate, be respectful, and be professional. You can view our code of conduct at hashicorp.com/community-guidelines. And I already see someone in the chat saying, go CTS. So we're very excited. With that excitement, we're going to go on to our actual office hours. Would you all on the CTS team like to introduce yourselves? I'm going to start with the order of the, I suppose, the presentation / demo, Lorna, and then we'll go to Kim, and then we'll go to John.
Hey everyone, I'm Lorna. I'm a software engineer on the team.
Hi everyone, my name is Kim Ngo. I am a senior engineer and the team lead for our API tooling team.
John Eikenberry, another senior engineer on the same team as everybody else.
Yes, so this is probably one of the new projects that I will say might be one of my favorites. I am a Terraform person and I like Consul too. So this is a lovely mix of the two. And so, Lorna, can you explain to us what exactly is CTS, why it combines Consul and Terraform in the first place?
Sure. Should I have some slides prepared? Is it okay to show them? All right.
Yeah, go ahead.
I think I'm sharing my screen. All right, thanks. All right, so yeah, just wanted to give a quick intro on CTS just to get everyone up to speed. At the highest level, CTS bridges Consul and Terraform, just like the name. Basically, it manages resources based off of service information. And it uses Consul for the service information, and it uses Terraform to manage resources. So just to get a little into it, you might have something like this set up where you will have a Consul cluster. It's receiving the latest information about your services. Separately, you might have some network infrastructure set up like load balancers and firewalls. And if you want to use CTS, you would run the binary with a local Consul agent. It monitors Consul catalog for any service changes. So this can be a service registering or deregistering. If a service becomes unhealthy, you tag a service, etc. Basically, the service changes, CTS notices. And then when it notices these changes, it uses Terraform to create, update, and destroy resources to keep your network infrastructure up to date. So for example, if you have a new service that registers with Consul, you can configure CTS to automatically add the service to the load balancer. And then similarly, if the service becomes unavailable, CTS can help you automatically remove that service from your load balancer. So that was a little bit about CTS and what it does. I'll just show a little behind the scenes of what's happening. All right. So when you set up CTS, you'll need to write some configuration. And one of the configuration blocks is a task block, and you'll configure a task to monitor like certain console services that you care about. So in this example, we have a task that is monitoring the API service and the web application services. Your task is also configured with a source and a list of providers. The source is a path to your Terraform module. And the module contains like the logic and instructions of what resources to like build and manage. And then the module then uses the Terraform provider to actually carry out all the like creating, updating, destroying resources. So when CTS initializes Terraform, Terraform goes ahead and helps us download the module and the provider files. And then when CTS receives the latest information from console, when that service changes, it generates a file containing the like console service information. And then when it calls Terraform, it passes along the console information. Terraform uses that console information, the module, and the provider to update your network infrastructure. So I've been talking about network infrastructure this whole time, but actually CTS doesn't have to specifically manage network infrastructure. It can really manage anything. So long as there's a Terraform provider and someone authors a module, CTS can manage it. And the like demos that we'll have a little bit later, you'll see like CTS doing some managing of non-network infrastructure resources. I wanted to give a shout out to Nathan Pierce, one of our Consul solutions engineers. This top architecture diagram is made by him, and he has some talks on CTS as well. So be sure to check those out. So that was it for the intro, a little bit on CTS, how you'd use it, and what's going on behind the scenes.
Thanks. So Lauren, we have a question in chat. Ivan, who's one of our regulars, tuned in, and he asked, is it safe to assume that CTS is a little bit like Consul template, but instead of doing, let's say, using Consul template to create a configuration for Nginx, you could use sort of this Terraform configuration instead for a cloud network?
Hey, Ivan. So great question. So I think we'll definitely get a little into it. I know John has a little something prepared, but I'll preface and then anyone else can jump in. It definitely, CTS uses some of the mechanisms that Consul template will share. We actually refactored some stuff out of Consul template. It is similar in the sense that it is generating these templates based off of Consul information, and then these templates are like Terraform files.
Awesome. All right, so I guess let's dive into the demo. I don't see any other questions for now, and I think we'll probably have more questions when we actually demonstrate what it looks like. All right, so Kim, are you going to demo CTS?
Yeah, I can demo CTS, but it looked like John might have wanted to add something.
Oh,
Yes.
I mean, I can wait until I spot or whatever.
No, jump in. It's right in context. This is perfect. So even I'm curious. I know it may not be perfectly Consul template. So I'm wondering, what is it?
So okay, well we refactored all the stuff that monitors Consul and Vault out of Consul template into a separate library, which as we call HashiCorp internally. It's currently public, but it's alpha kind of. It's not finished. But we were using it for CTS, and eventually we'll reuse it for Consul template. We're going to refactor it to use that. But it manages all that, and it's got some nice kind of features that it grew during the reworking that some mainly scalability improvements and that kind of thing. I can go into it later. I don't know.
Interesting.
And,
I didn't know. Okay, so, HashiCat, right? It's CAT.
Yeah, it's HCAT is the thing, but we just call it HashiCorp for short.
Oh, okay. All right. Can I ask why it's called HashiCat?
Well, it stands for like HashiCorp. What was it again? What was it? Configuration and templating. That's it. Configuration and templating. Because it's for generating for using templates to generate configuration files for either like with Consul template, whatever it's being used for, in this case, it's being used for Terraform configuration, but it was the I don't know, naming. We couldn't come up with like a good name, so we just did the anagram thing, acronym.
That's awesome. I like HashiCat.
Yep. And I don't know, again, I'll go into it more later when it's my turn.
Oh, okay. All right.
So
on that note,
my turn.
It's a cliffhanger basically, but now I'm very curious. So let's start with showing what it is, and then we'll start deep diving into what exactly is running behind it.
Perhaps I think the demos are going to be reversed, where like it's going to be pretty much a deep dive, and then John will cover like how it runs smoothly. So sorry about that swap, Rosemary.
Yeah,
it's okay. It's fine.
All right. So what I'd like to share and demo is my setup on how I build a console integration for CTS. And that is effectively building a compatible Terraform module that works when CTS runs it in automation. And what's great about this integration is that it's pure Terraform. And so that means you can develop, test, and run it just using Terraform. And then like slowly as you're more moving forward with your module, you can then integrate CTS to see the automation parts, how it works together, that your module works with CTS, and then see it running in a continuous manner. So my portion of the demo is focused around the persona of a network operator who's building a Terraform module specific to their own network infrastructure to be ran with CTS. CTS is a really relatively new tool, and so the ecosystem around reusable modules is still growing at the moment. We're partnering a lot with partners to build out these ready-to-use modules. But if there's not one that currently fits your exact needs, you can definitely build one out for yourself. So on my left side of the screen, I have a main.tf, which is the main entry point for Terraform, and where it strings together like the core logics of the instructions of what it would be managing. And I'm just using a local provider, so I have it where I'd like to have a file each for each console service, and then in each file have all the IP addresses of them. So it's a very like simple, straightforward example to tinker with and begin with, just to familiarize yourself with like building a module for CTS. So there's two main requirements for a compatible module. One is the main.tf, and then one is the variables.tf file with a variables services declared. And this is effectively like the contract between CTS and the module, where it is the console information that gets passed from CTS to Terraform. And the structure is a map of service objects. And this sort of information is effectively console service information that you would get from the console API, specifically the health services endpoint. So right here, I have the local file, and it's looping over the console services. And I have the locals block, which transforms the var.services into a way where my resource can match what I'm trying to logically represent. And that is services grouped by the logical service, and then have all the instances in between. So this is like a manipulation that I had prepared already, but it's honestly kind of hard to follow just seeing the pure Terraform, and not easy to follow like visually what the structure looks like. And so a method that I always commonly resort to is using Terraform outputs to see what this data transformation actually looks like and ends up being. So I'm gonna, it's always nerve-wracking coding live.
It's okay. So something to make note of, a lot of these, iteration capabilities and the object structure that you showed before is only something that's, I guess, newer to Terraform 0.12. So does this work for anything earlier than 0.12?
That's a good question. With CTS, we had pinned it to support Terraform 0.13 and forward. And 0.13 was the idea behind that is because that's when third-party providers were introduced. And you can now use Terraform with a non-official HashiCorp Terraform provider.
Good to know. I did not know that.
So yeah, my next step would be the common Terraform commands. I'm gonna initialize it. Yeah, so when I start off, you can just purely use Terraform as I mentioned earlier. Oh, one thing I forgot to mention is, so with this variable.tf, for testing purposes, I also commonly declare a tf-vars file to set the value of this variable. So I have one prepared. This is one that you can probably find in the repo somewhere or in the docs. I'm just gonna copy it over here. So this is just like not what the typical values you might see from the health services endpoint. So from there, I'm going to Terraform apply this. Cool. And then it looks like it's creating it would create two text files as my resource had wanted, and then an IP address for each. I'm gonna go ahead and approve that. And this is what Terraform outputs prints out, which is really convenient, is that I can now see what the console services, this local console services actually looks like in the structure. So it converted this like map of objects where this is the ID to the object itself. Now it's the service name to a list of the object instances or the console service instances. So that's looking pretty good. I think it's a pretty good point where my module's at a good point where I can now like introduce CTS into this. For that, it's pretty small setup since I'm not connecting directly to a network provider right now. I'm going to start up console.
Can you bump the size on that one a little
This
bit?
one's not too important. This is just going to spew console logs in dev mode.
Okay, so those who may not be able to just, like view the gigantic pile, it's a bunch of logs. So there's nothing, you're not going to reference anything in the logs, I suppose. So don't worry, everybody. Don't worry. You're not missing too much.
And yeah, the more condensed information might be useful here. Querying the console server catalog. Yeah, there you go. We have several services already registered with console. And now going over to the CTS side, I'm going to build a configuration file to run CTS. So I have this configuration file prepared. It is standard HCL. This is like pretty bare bones CTS configuration where I just kind of want to see all the logs, enabling the Terraform logs within the CTS logs. So it's kind of inception there. And then a task block here. This is what Lorna had mentioned earlier, where this is basically the definition of what you want automated. And it's saying that I want to use this module and have CTS run a Terraform plan or apply based on changes to these services that I'm wanting to monitor. Yeah, so this like source is my local path. Config file, I'm gonna point it to that. And then I'm running it in inspect mode. So inspect mode is a very useful tool for quick development purposes and just like really spinning up on CTS and learning all the things that it does without actually changing infrastructure. So what this does under hood is it goes through all the tasks in the configuration file and it runs a Terraform plan. And with plans, you can see what the proposed changes are without actually applying those changes. Other useful aspects of the inspect mode is that it validates the CTS configuration. It can quickly get really, really large when you have multiple tasks, different services, and a handful of providers all in configuration. And so it validates the structure of the HCL. It would also conveniently validate like if there were credentials required for the module and the providers it uses. All right, so I'm running the command now, just to stretch this out a bit. I'll briefly walk through like the logs of what's exactly happening. All right, from the beginning, you'll get like just information about the configuration. And then what CTS does is it automatically installs Terraform for you if it doesn't discover one in that current working directory. And it'll default to like the newest one, or you can also specify a version between like 0.13 and beyond. Another important aspect of the setup is when it initializes the task. What this initialization means is that it is generating auto-generating Terraform configuration files. And I'm going to quickly walk through several of them that get generated. All right. And those files get generated in the working directory sync-tasks. That's the default location. There we go, open. And then it's organized by subdirectories of each task. So what gets created is a root module that then accesses the module that you chose for automation. And the way it does that is it creates a module stanza, which then points to the module of your choice, which is the child module in this case. And then from there, it also passes the services information to your module. Other automated stuff, this is the default console backend that's used for Terra. Oh, sorry, I'm gonna step back. With CTS, it automatically will use the console KV store as the backend, and that's where the state file will be stored. You can definitely configure the backend to another option that you might be using already. Another file is the terraform.tfr. So this is CTS queries console, gets all this information and writes this out to this file. So this is actually what is registered with console right now. And how this is done is that this terraform.tf files gets updated as new services are discovered and adds it to this file by using the templating. So this is a mixture of Go templates as well as the HashiCorp specific templating functionality, which we were talking about earlier, HashiCat. And so this is very, very similar to console templating. So that's the main gist of the root module that gets auto-generated by CTS. Let's see, what else can I walk through right now?
Can you explain a little bit about provider credentials, right? So, if you're using AWS or Azure or, F5, if you're using any network provider, you're responsible usually for passing some form of credentials. How does Consul-Terraform-Sync handle those?
That's a good question, and probably a very important question. There's several ways to configure your Terraform providers through CTS. And CTS we've made some intentional steps to best secure those credentials, as well as like not write them out to plain text if necessary, we can avoid. This is a pretty bad example because I'm not using a provider. Well, what would end up happening is that CTS would generate an intermediate variable for that provider. And it would proxy all the information from the CTS configuration from here and obscure it in a way where it's saying like you have the arguments that are similar to what your provider would have. And so what would happen in your TerraBFRs? Yeah. I'm a bit lost right now.
It might be here. I'll show mine. Mine is not updated to the most recent. So everybody be careful. There will be likely keys that I may or may not have accidentally not redacted. So we're going to attempt to redact them now, and then I'll share my screen so you can at least see, because they are currently the version I have combines both the provider block and the services block in one page. So we're going to be careful not to show keys because that would be really bad. Although they're probably not valid anyway. So yay for vault and ephemeral keys. Okay.
And then in conjunction afterwards, I can share like where in the documentation you could find to help secure your provider. Because pulling this out, right, typing it live, I'd be kind of lost.
Yeah. Let me bump this up a little further for those who are seeing this. Okay, so this is what would be in the providers.tf here, correct? This thing.
Yeah.
Okay. So this is the, let's say, AWS provider, and these are my access key, region, secret key, etc. token. And then if I take a look gander at the module, so these are sort of like my variable modules, everything else here that has been templated for me. And more importantly, let's see, the providers. Here we go. So this thing here. So because I've defined the access key, region, and secret key, it will map it to this provider block.
And then there's another step as well where you might have seen in the TFRs of Rosemary's file that it also has like the secret key there. A way you can avoid all of that is still using the Terraform features of the provider where it supports loading from the environment variable as well. And so it would not even be written to these files.
Cool. So I could define like AWS _ access key in my environment or in my shell and run CTS and be able to still, pass this in as normal.
Yeah, exactly.
Awesome. Okay, let me just stop sharing.
All right, I'm gonna steal the share back. Was there anything else that I might have missed on configuring your provider? Oh, Rosemary, you're muted.
Sorry, thank you. Any way that I can pass my own variables files and, does that override, does that merge? How does that logic affect the variables that are getting templated or rendered by CTS versus the ones I want to pass in?
Nice. That's a good question. I can actually demo this. So in my main.tf of my module, I'm going to declare a variable here. So right now it writes the IP address to the files. Let's say, what if I want to also write the metadata to the file and make that optional for operators like who would be using this module to like configure, yes, I want the metadata or not. So I'm going to go to the variable.tf file for the module, declare one. And I'm also going to declare it a default value. So this makes it optional where the CTS user would not have to define one if they want to have it false, but they could assign the value if they wanted to set it. And then in the module itself, I will consume that variable here. Okay. Yeah, that looks good. And then, so over on the CTS side, what operators would need to do is add a new attribute here, variable file. Let's create a file on the right side. Set the path here. And in this input bars, I'm gonna set metadata, where I already did apparently. Set metadata to, or this variable name to true. So I'm gonna go ahead and run this, but now in once mode. And so I saw the inspect mode, I saw the outputs, and then I want to move forward with it. So now I'm going to move on to once mode. And this mode is also useful for development to realize those changes and only once, just to verify like your module's doing what you want it to do before you fully run it in automation. So what once does, it runs through all the tasks and runs a Terraform apply on them. Done with invalid keys. Variable file. It is plural. I have a typo.
Is there a way that I would run Terraform validate as part of CTS? Or I should do that outside of this?
You could definitely do it within Terraform. So this is the directory for my module. Thank you. Actually, characters in. Oh boy.
Live debugging.
Live debugging. I'm just going to copy and paste what I have prepared.
For those Terraform experts out there, you know,
feel
free to.
I do not claim to be a Terraform expert by any means.
Oh no. Oh no. There's a lot of functions that will do a lot of interesting things. So.
There we go. Yes. Okay. So 2 files were created, the API and the web. And I'm going to hop over to where they are created. And yeah, I have now the IP address and metadata for those services. So with API, I guess everyone's Team Burrito. And then over on the website, people are Team Taco. All right. So my module is, oh, go ahead.
I love that. I was going to say.
My module is at a good state where I'm comfortable to publish it. So what publishing a module is useful for is to like easily share a module with somebody else. So I can share it with Lorna or John pretty quickly. So the steps to do that, I'm gonna push it up. Oh. And then go over to GitHub. With my module, I'm going to cut a release. That is not it. Release. And then I'm hop over onto the Terraform registry side. Go ahead and publish a module here. Awesome, it's published. And what's really cool about the registry is that it parses through not only the README, so it'll include the documentation in the registry as well as like parsing through the module itself for inputs, outputs, and dependencies. So you can see here where we included the metadata option here. Now going over the CTS side, I can change the source to not point to my local one and point it to the registry path. That'd be namespace slash provider, or the module name, and then the provider. Yeah. And you can also specify the version of here as well. Let's run it. Yeah, so now you'll see that it is Terraform is discovering the module and downloading it locally to then be executed on. So that concludes my demo around like interacting with CTS, tinkering with your module, and then publishing it. So this is very like Terraform focused. However, it doesn't always have to be this way. You will find yourself in this position if you are developing a module for your specific network infrastructure. However, if there's a module that you have found that works exactly for what you need it for, running it will just be configuring this configuration file for CTS, and it's pretty straightforward there. So I'm going to hand over the demo to John, unless there's any other questions, to show what CTS looks like when it's running smoothly in automation.
I don't see any questions in the chat. There's only one thing in terms of the resources. Do you have a module template that someone can use if they want to get started developing their own?
Oh, yes. I'm really excited about this because this is like really, really new. We have built out a template repository on GitHub. Increase the size here. It's a Consul-Terraform-Sync -template module because we're just going to concatenate everything together. And you could use this as a template to begin creating your own module. And what's very cool about this is that in several of the files, you'll have instructions to guide you through on how to document your module. And then over on the main.tf, you'll have some like blocks that you could fill in with comments on guiding you through building it as well as a up-to-date variable.services. Instead of having to find that somewhere, create your variable.tf file and then copy and paste it over here. So this is a great starting point for building your own module. And we hope to build this out, like expand its wiki and just be a good source for people and for people to build modules and lower the barrier to entry to create integrations.
Awesome. I'm excited now to see what happens when services change in Consul and how that how that affects what CTS will do.
All right, that's mine. All right, but first, I'm going to finish my thoughts earlier because just the essentially, I just wanted to say kind of how quickly how it monitors things. That it basically uses the same kind of setup that Consul template uses, but it's been, like we said, abstracted out or refactored out into a separate library, which we did for this project, and we have other projects that use Consul template, have used Consul template as a library, and it wasn't really designed for that. So this was part of creating a library that for the kind of the templating functionality that does the monitoring stuff without everybody, without trying to develop, not in there, but without it being in Consul template, because it was a really bad interface when used as a library. Anyways, okay. So the way Consul template and the way this new library, the HashiCat library, as we call it, monitors things. Right now it supports Consul and Vault, and Consul primarily is monitored using like long polling blocking calls, where it just opens the connections to watch the values, and then as soon as there's a change, it sends the response down the channel. And then for Vault, it uses more of like a polling system, but it's kind of smart, where it uses the Vaults kind of like, you can set up Vault leases with time that they're like, what time periods of how long they're good for, or it has rotation period settings you can do. So then it can pull based on how long the credentials are kind of supposed to be good for, or just a predetermined rotation schedule. And so it's just like, those are the two main ways it kind of just monitors things. And let's see. So then I wanted to say that the HashiCat refactor included a couple of improvements that will eventually get back into Consul template too. And one is that they're both around scalability. The dependency tracking is a lot better now, so that before in Consul template, when anything changed, all the templates would get re-rendered because it had no idea which monitored things went with which templates, and that's fixed. So it only will trigger the templates that need to be resolved, which not as important for you people here, but any Consul template people around might be happy to hear that. I mean, the other thing is that it's going to use HTTP2 connections to the local agent, which will get rid of the issues that there have been around hitting the maximum number of connections issues with the local agent. Because with HTTP1, every one of those blocking connections, every one of those monitored values would have a separate HTTP1 connection. So you can hit the maximum if you have monitored too many things fairly quickly. And then, but if you use HTTP2, it's all over one connection, and so it just completely eliminates that issue. All right, then, so let me share my one window here for this demo, I'm just going to mainly demo, let's see, this one. All right. I'm just going to be demoing kind of running CTS with a console, and then just kind of, I'm going to be just manually adding and removing stuff from console. So let's see. First, I want to get console running. Let's see. Oh, wait. Actually, I don't think I created a window for that. Oh, there's a jet. Sorry if you hear that. All right, here, let's see. Let's start it. Okay, this is just running the console server. Let's see, this was here, so that, okay, this is the two. I have a couple simple API things that are kind of just registered or in the console configuration to register it. And then I also have a couple of web ones that I'm going to add, but for now, let's see. That's good. So let's see what, on this desktop. Okay, this is where it's going to spit out the output files. This is the same setup as command pretty much, where it's just going to put files in here that have IP addresses in it. And we'll watch that later as for when I change stuff to show you how fast stuff gets. So start up with CTS. Let's see. Let's switch back to that real quick. See, they're already there. See, it's service. So wait, out service. See, it's just, they just have little IPs in them, and those corresponded with the configuration ones in the config file that I showed you. So they're there. All right, now let's see. Now we'll go to. So what I'm going to do is, I'm going to basically, that's later. I'm going to basically do this. I'm going to do this in another window so that you can watch the output thing at the same time. Good. So let's see, where's that output? There it is. All right.
John, are we supposed to be seeing multiple windows right now?
I don't know. Are you?
We see one, if that's.
Yeah, okay. If that's what you're doing, I just
Okay,
have
cool.
the one window that's got the screen running it that I'm watching. That I'm gonna run this command. The console just register the service. I'm running it in a different window, but I mainly
cool.
want to focus on this is just, you can't tell, this is a watch. It's just basically, it's running an update on this. It's every 0.1 of a second, every 1/10 of a second, it's updating this. And so you can just, there's a way to see how fast it updates. As soon as I get around to actually getting the command run. Here we go. Finally, forgot to have a window ready for that. All right, so I'm going to add that first web entry, and so and right now I'm hitting the enter, boom, and boom, there it is. So it's basically, it's as soon as it sees it, as soon as it's added to console, the blocking query is triggered, which runs CTS through its process of rendering out a new template and doing all and running the services, and just basically, and then this is then it prints out the service. And so this is how fast it would trigger a call to Terraform to run the Terraform script to update the end service, and then depending on how long the Terraform took to take effect, that would be how long it took to update the service and charge. And then I was going to do it. I got side 2. I'm going to do that 2 here. See, and then so there's the second one, boom, and then I was just going to unregister one once just to show that it disappearing. There goes. All right, I just services. It's deregistered and not unregistered. There it goes. Okay. So that's, I just wanted mainly to show off how quick that is to go through and just how fast it updates after when it's just kind of running in the background all the time and it sees the console things, and then it gets the update out fast. And then I was also going to quickly, where's that window? All right, this window focus. All right, hold on. There, okay, yes. We also, I was going to quickly show off that we have a status endpoint on the node that can be used to tie into other systems. For straightforward right now, it has a general high-level tasks endpoint that it hits that shows kind of the overview of everything. And then let's see, there's this one. So the website, that's the name of this little, that uses the task name. That's the task name is the website. And then this includes the events. And I'm typing, this is a little JSON printing printer thing, so that it's not so ugly. But then, so this is more details where it goes into the providers. Then it talks about, and then it has the different events that happened, which would be essentially kind of the help text, or if there's any problems each time you do the kind of any things to update, an event occurs, and if there's problems, it would get entered here. But yeah, these are all error-free, but it gives some basic information. And then, oh no, that's it. So I guess that's it for my presentation.
Awesome.
I will
Yeah.
unshare.
So I guess there's a couple questions in the chat about what are some use cases behind it. So we went through a lot of the internals and how it's synchronizing. So what are ways that at least some of the folks who have tried it have told you, like, this is how we're using it, this is where we find it really effective for our automation?
Well, I'm not sure. First,
Rosemary, I can take that.
Thank you, Josh. Thank you.
We have Devarshi who's going to answer, but I mean, there are a couple of interesting use cases. I posted a blog when CTS first came out. What happened, at least for me, from a practical standpoint, at one point in time, I was responsible for basically traffic splitting, basically manipulating DNS, for example, in a data center. And so we ended up writing a lot of scripted glue automation. I claim it's scripted glue automation. It was bash scripting, everyone, and some other weird things. But basically what happened was that anytime, the problem was we had a containerized environment that updated really dynamically, but a DNS that was in a data center that was really hard to update. And so we had to write our own triggers, for better or for worse, that anytime a new container got registered or a service changed, we had to reflect that in a load balancer and then make sure the changes, if the load balancer needed changes within DNS. So it was a pretty big mess. And so recently, when I tried CTS, what was really neat was that I was able to register services very dynamically in Consul. So if I had a container environment, in this case was Kubernetes, I could create the Kubernetes services, they would register in Consul, and then I could basically update any of the IP addresses on my load balancer, listener rules in AWS, with the correct IP addressing and the correct ports. So some of this is it really will help drive, if you're familiar with using Terraform in a data center, or if you're really familiar with using Terraform against any network automation in general, it's the ability to take that service metadata that's really dynamic and manipulate a dynamic system into a static environment. And that's what's, at least for me, really cool about this. I know that some of the modules are firewall rules. Some of the modules that others have written are load balancers as well. I think F5 is in there too. And there's some others who have used it. I don't know, has anybody used it outside of networking as well?
So Rosemary, we have users who've essentially enabled target group updates on ALBs using Consul-Terraform-Sync. We have users who essentially, when you deploy a service, you want to bring up an ingress, right? So you use Consul-Terraform-Sync to do that. So I think there are a lot of real-world cases which users are already using. But if you think about the general category of use cases, right? First is the pool member updates, whether it be your on-prem F5 firewall or load balancers, or be it ALBs and target groups there. But the use case that it enables is pool member updates. In terms of security tools and appliances, in case of firewalls, the workflow that we've come across is you have these firewall rules, but the endpoints, which are part of the source and destination for these firewall rules, are pretty static. And the update process to go ahead and update those members to reflect the right set of source and dest policy has taken time. It takes a lot of time. So what Consul-Terraform-Sync does in that case, it goes ahead and updates those members for the firewall rules as well. So think about it as taking the dynamic nature of the service registry that's there in Consul and applying that to, as Rosemary said, static infrastructure in most of the data center as well as some cloud environments.
It's really awesome. I think what's impressive about this and something John, you demonstrated a HashiCat, right? And basically it's a better way to do this process, right? Of basically taking information from Consul and, putting it in some kind of templating or some kind of target. Are there ideas of other parts of Consul that HashiCat would be able to retrieve and put, could it be configuration entries? Could it be key value stores, kind of similar to what Consul template already does?
Yeah, it supports everything that Consul template did. So it supports monitoring not only the services and their health, that type of thing, but also key value stores. It actually supports some of the connect functionality. It can get to certificates from the services and that sort of thing. We'll expand on that as we need to. And we're like right now we're in the middle of we're upgrading some of the interfaces to the newer version. There's a version 2 of some of the stuff that support some other options that weren't in the old versions, and so it'll keep evolving, and we're planning on possibly even adding other kind of backend sources to it as well.
I just heard certificates, and then I got very fascinated. So I could retrieve using HashiCat. I could retrieve the certificates from Consul, correct? And I could do something with them.
Yeah, Consul has its connect functionality, which is its mesh networking setup, and you can use some certificates to bring add things to or have things work in with the mesh network by getting the certificates that you need from Consul, because it works as its own CA when it's in that mode. That's so it can be useful for integrating things with the mesh networking as well as with the discovery system. I don't know if anybody's doing that yet, but that's supported in the templating stuff.
Be careful what you ask for. Someone's bound to do something with it now. I may even use it. I'm just, I may borrow it. All right. If anybody has any other questions, we're coming up on the hour. Please post into the chat. I know we've had some great discussions and a number of folks who've raised their use cases as well. Sounds like someone's been working with the Cisco team to use CTS for on-prem network gear, which is really cool. And I imagine there are many other ways. I mean, the Terraform module, it's not restricted to networking, right? It's just if there's anything on the Consul services right now, at least, that you want to synchronize to something, it will support any arbitrary Terraform module, correct?
Yep.
Awesome. So I guess the big question is, what's next?
Oh, I might punt that to Devarshi, if that's all right.
All right. Hey, thank you for that question, Rosemary. And I think that brings us to a very important point. The way we see CTS is essentially enabling a publisher-subscriber model. So the first release that we are planning for CTS, which is beta in March and GA in early April, will be focused on enabling practitioners through Terraform open source. But the future set of features and enhancements and integrations that we are looking at are more towards enterprise requirements, where integrating CTS with Terraform Cloud, with Terraform Enterprise, and enabling the enterprise capabilities around governance, around policy, as well as auditability is something that we're looking at. That is one set of integrations that we're looking at. And other aspects that we're looking at in terms of CTS are what additional triggers can we enable into CTS, right? So right now it's services that the user can subscribe to in CTS. We are exploring KV as well as one of the potential triggers. So I'd love to hear from the community as to what use cases they envision with CTS and how we can enable the right set of triggers and right set of enterprise requirements around CTS as well.
Awesome. So what I'm going to do is I'm going to drop, if you have any ideas, thoughts, or comments around CTS, either, use cases or features, and there is the GitHub, but the team is actually also monitoring the Discuss forum. So feel free to drop a new topic in there, articulate the use case that you're working on or interested in sharing. It sounds like there's some ideas already. So with that in mind, I think we're going to close out for today. There are a few announcements as well. As a reminder, tune into Hashi Talks next week. We have amazing community speakers who will be basically presenting their usage of HashiCorp tools and DevOps tooling in the DevOps space. So definitely check that out. We're also live coding on Twitch, so do tune in on Fridays. We have usually someone live coding in both European Asia Pacific hours as well as the US Pacific Coast hours. And there are more community office hours coming this month. Since Microsoft Ignite is happening the first week of March, we'll actually be holding some deep dives for you to ask questions about everything HashiCorp and Microsoft Azure. So if you have interest, any interest in how HashiCorp tooling works with Microsoft Azure, feel free to drop questions in the office hours, discuss, and anytime, just tune in, drop your question. We'll have them for all of the tools. So with that in mind, thank you all for joining. Appreciate you taking the time and actually live coding. I think that's the first time we actually live coded on one of the console office hours, which is fun.
Oh, I should have done that beforehand and recorded it.
Kim, you did great. You did great. You did great. And thank you, John, for showing HashiCat, which is technically HCat. But I'm going to call HashiCat from now on because it's easier.
Spelled HCAT, pronounced HashiCat.
Okay, awesome. And thank you, Lorna and Devarshi, both of you, for talking about CTS and what exactly the process looks like and what's next. With that in mind, thanks for tuning in, and we'll hear from you at the next office hours.